Hello everyone, my name is Manvi Sinha and I study in Sri Venkateshwara College of Engineering. My USN is 1VE23IS028 and my subject title is Computer Aided Engineering Drawing and its code is BCEDK203 and my today's topic is projection of lamina. Firstly, we will discuss what are projections. Projections are methods of representing a 3D object on a 2D plane. It is used to communicate detailed and precise information about the shape, size, and features of an object. Firstly, we will discuss a problem statement on square lamina. A square lamina ABCD of 40 mm side rests on corner C such that the diagonal AC appears to be at 45 degree to VP. The two sides BC and CD containing the corner C make equal inclinations with HP. The surface of the lamina makes 30 degree with HP. Draw its top and front views. So the given data is a square lamina ABCD with 40 mm sides. Diagonal AC appears at 45 degree to the VP. Sides BC and CD make equal inclinations with HP. The surface of the lamina is inclined at 30 degree to HP. So here is the solution. We will discuss steps to draw the projections. First, top view. Draw a square ABCD with each side 40 mm. Ensure that diagonal AC is inclined at 45 degree to the horizontal axis, representing VP. Then front view. From each corner of the square in the top view, project lines vertically downward. Since the surface of the lamina is inclined at 30 degree to HP, tilt the square accordingly. Imagine rotating the square so that the surface makes an angle of 30 degree with HP. The height of the tilt can be calculated using trigonometry. Height equal to side length into sine 30 degree equal 40 mm into 0.5 equal 20 mm. Draw the front view showing the square inclined at this height. Now we will discuss diagram of square lamina. Top view. First you draw a horizontal line for the difference. Then draw a square ABCD with diagonal AC at 45 degree to the horizontal line. Label the points as A, B, C and D. Then in front view, draw vertical projection lines from point A, B, C and D. Draw the inclined square such that its height is 20 mm above the base. Label points A, B, C and D accordingly. Now we will discuss about rectangular lamina. So here is the problem statement on rectangular lamina. A rectangular lamina of sides 20 mm into 30 mm rests on HP on one of its longer edges. The lamina is tilted about the edge on which it rests till its plane surface is inclined to HP at 45 degree. The edge on which it rests is inclined at 30 degree to VP. Draw the projections of the lamina. Given data. A rectangular lamina of sides 20 mm into 30 mm. The lamina rests on HP on one of its longer edges. The plane surface is inclined at 45 degree to HP. The edge on which it rests is inclined at 30 degrees to VP. So here is the solution. We will discuss these steps to draw the projections. First, top view. Draw a rectangle of dimensions 20 mm into 30 mm. Position the longer edge horizontally, representing it resting on HP. Incline the longer edge at 30 degrees to the horizontal axis, representing VP. Second, front view. From each corner of the rectangle in the top view, project lines vertically downward. Since the plane surface is inclined at 45 degrees to HP, tilt the rectangle accordingly. Imagine rotating the rectangle so that the surface makes an angle of 45 degrees with HP. The height of the tilt can be calculated using trigonometry. Height equal longer side length into sine 45 degree equal 30 mm into 0.707 equal 21.2 mm. Draw the front view showing the rectangle inclined at this height. Then, diagrams for rectangular lamina. For top view, draw a horizontal line for the reference. Then draw a rectangle of dimensions 20 mm into 30 mm. Position the rectangle such that its longer edge is inclined at 30 degrees to the horizontal line. Then label the points as A, B, C and D. Then in front view, draw vertical projection lines from points A, B, C and D. Draw the inclined rectangle such that its height is 21.2 mm above the base. Then label the points A, B, C and D accordingly. Conclusion. Accurate projections are vital for effective engineering communication and manufacturing precision. Mastery of drawing projections is a fundamental skill for engineers and designers. Thank you.